All right, so here I am saying that this is new, but during the 1800s, oh my gosh, that doesn't seem very new. And possibly during Newton's time, there was evidence that particular materials, such as, and I've mentioned this already, Icelandic spar, could polarize light rays. And what does Icelandic spar look like? It looks like the frost on your windshield in the winter. Like it really looks like long crystals, okay? Anyway, the idea here that I want to present just now is this idea of the picket fence model. The picket fence model says that if I have light coming from, and this is supposed to be a flashlight that's sending unpolarized light at a polarizer. And if I zoom right in close on this guy, hopefully you can see that polarizer has vertical orientation to it. And the next polarizer also has vertical polarization to it. And the way that the picket fence model works is this, and maybe you've never seen a real picket fence, maybe you've only seen it in old-timey TV shows, but if I take a skipping rope and I wiggle it up and down through the slots of a picket fence, then you should also be able to have a second picket fence, a few feet away, and it will also wiggle up and down, right, without any attenuation or dying out, right? With the picket fence model, if I take the second picket fence and I make it be perpendicular to the first picket fence, then the second picket fence, notice that it kills the wave. And I've kind of been trying to sell this a little bit with the idea of why we have sunglasses that are at right angles to the reflection polarization. But this is kind of like a nice visual for us, okay? It really doesn't get at the mechanism for why it happens. You do have to go back and talk about current induction and resistance and all that sort of stuff to talk about the why. But at least gives us a nice pattern, okay? So the picket fence model is a good pattern for talking about killing that wave by having right-angled polarizers. So the picket fence skipping rope model results in absorption of unaligned light waves and wave components. And polarizing sunglasses, we got to fill in that blank. Polarizing sunglasses work to remove sunlight energy, protecting your eyes. Okay, so really the polarizing sunglasses are taking that light that's reflecting off of windshields or the lake or whatever, and it's blocking out all the light, or as much as possible, of the light that's at a perpendicular polarization. And then as a quick little fact from the fact man here, cuttlefish can see polarized light. That's cool. Cuttlefish are already cool for a variety of reasons, but the fact that they can see polarization of light and we can't, I think is kind of neat. That's like a superpower, right? And people say, why would they want to know be able to see polarized light? How could that possibly be a survival advantage? And there are people that have ideas about this. One reason could be that cuttlefish might be able to see the reflection of faint light off of their prey. And in the same way that sunglasses are going to pick up whether there's been a reflection off of a horizontal surface, if cuttlefish could pick up that there's been a light reflection off of a horizontally oriented or vertically oriented fish that they like to munch on, then that might be almost like adding a contrast filter so that they can see the stuff they want to go eat. Cuttlefish are amazing.